Hi, good afternoon, everyone. Um, so a little bit background why we started doing this optimization of the cost. Um, in our database platform industry, we have a trend that we are moving from on-premise to cloud, the migration, and optimize later on as a phase two. So we'll talk about how we did it in Indeed, the optimization part of the cost. But before everything, who we are.
So, introduce.
We help people get jobs.
We help people get jobs. So we were supposed to say this together, but
Right.
it didn't happen. Sorry.
So we help people get jobs. A quick introduction for myself. Chitradeep Chakraborty. I'm a senior manager in Indeed.
And
my
I'm
colleague.
Manan Shah. I work with this guy. Sometimes he's a pain, but he does pretty good shit. So I have to just put up with him. But
We
like
stick
if you,
together.
if you have heard my BS before, this is real shit. So just take it very seriously.
Okay. We are going to cover a lot of stuff, so we'll try to move fast. And we'll take the questions towards the end. We have kept at least 5 minutes for that. So a quick timeline. So we already had an indigenous platform that's called Quartermaster, where our clusters were running before migrating to MongoDB Atlas. Back in 2022, we decided our partner as MongoDB. We wanted to have a managed database platform so that we can focus more and more into the product developments. So a quick timeline that we started our migration from our Quartermaster platform in around June, and we completed in November last year. And during that time frame, we observed that the high cost is there. We are in Atlas. And we already initiated the cost-saving program for Atlas. At the same time, in January this year, we had an organization-wide mandate to reduce cost by 19%. So we had to follow that mandate. So the objective was to reduce the Atlas cost by 19% as a part of the mandate to reduce our overall cloud spending by 19%. Now, because we cannot give you the numbers, how much cost we saved in $1 million or in dollars, we are going to give you an idea about our footprint. Possibly you'll have to deduce that, what kind of cost saving we are going to talk about. So we have around 600 plus clusters with 500 terabytes of data. The first thing is the strategy, how we plan our attack, where to start with. So we have our analytical platform that's called IQL, Imhotep Query Language, and that's the platform we used for our analytics. What we did during the analytics is we basically made the API call of the billing module of Atlas, and we put everything into our analytic platforms so that we can further slice and dice data based on the cluster size, based on the clusters, based on the projects, and further details into each and every category. You can use your own analytics platform, but this is what we did, and that's what we wanted to share. Some of the important outcome from that analytics is, first thing first, that 85% of our total cost was from 40 specific clusters. And we knew where to attack or start the attack. And this is exactly a snapshot of our billing back from November 2023. I'm showing the top 8 SKUs. SKUs are the stock keeping units. You'll find this in Atlas invoice. And these are basically shows where we are spending most into the bucket of Atlas spending. So for obvious reasons, it's very clearly understood that the instance cost or the compute cost is on top with 43%, followed by the 30% of cost, which is contributed by the premium features and support. And after that, we have storage, backup, and the data transfer costs, which is like the private endpoint and AWS data transfer. So accordingly, we prioritized our strategy. We are going to target the top 40 clusters optimization, followed by reviewing the premium feature and the support. And after that, backup storage and data transfer optimization. At this point, I will hand over to my colleague.
Thank you, sir, and thank you for putting up with me so far. We will discuss a little bit about cluster optimization. Before I go, I would say that I won't be able to go much detail into every single technique that we have used, but this will give a basic key points on how you can basically optimize or cost optimize your cluster. So this is the basic strategy. Of course, we start with the cluster that is burning the most money, and then we generate the metrics and go in phases and work with the product teams, and then track cost in IQL and so forth. We initially engaged, I think this slide is a little bit. We engaged our MongoDB professional support who helped build a tool called interrogator and determinator. Now what tool that does is it queries, it takes an input as a cluster, and then it will, with a command line, it's a Go application with a command line arguments, you can specify the name of the cluster, whether it's sharded or not, but then once it analyzes, it goes into the cluster, checks all the details, including the traffic on that cluster, the volume for a given period. Like if you specify like 7 days, it will analyze the last 7 days of workload and then generate a recommendations, like 10, 12 different recommendations for each cluster. And that will give a variety of options. Like you want to have 3 shards with 7 replicas. Now you can also have 5 shards with 3 replicas each, and so on. And then we can pick and that will be basically serving the same type of load. And then you pick a cluster, pick a recommendation that is the best suitable for your workload, and you go from there. And then you, of course, you implement that in phases, and you monitor the cost. Coming on to the CPU utilization. So the most important thing in the CPU utilization is there is a low tier CPU. So what we did when we first migrated, we were like whatever we had on the quartermaster, we have implemented equal amount of CPUs or the sizes. So what we realized was a lot of clusters were burning just so much resources that we can easily, lot of low workload clusters, we could just easily go to a lower tier. Like for example, for M40, we can go to an R40 with a low tier, and that would immediately save 25% of the cost, depending on the cluster tier. Next up is the shard optimization. So we worked with multiple teams on our product to make sure that the shards are equally balanced, because what happens when we migrate, there are shards that are not heavily that are pretty heavily utilized on the primary, but then there are empty nodes or empty shards because a lot of collections like will reside into the primary collection. So we want a primary shard. So we want to make sure that the shards are equally utilized, because MongoDB today does not offer the advantage of having different shards sizes. So we have to make sure that the shards are equally utilized, and if there are jumbo chunks also we need to take care. Again, resharding is also a very costly exercise, so be aware that there could be performance impact. But in brief, empty shards can cost more, and therefore it's best practice to have the shards as equal as possible, or as full as possible. So the replicas optimization is a little bit more interesting, because we go into the metrics and monitor the SLOs from the application viewpoint. Now, if I can go from point A to point B in a Toyota Corolla, do I need a Ferrari to go the same place? So some of the applications, we realized that they were actually using a Ferrari to drive where their application business logic did not need that high level of performance. And we could easily, so that's the most important part is like, once you have the SLOs in hand, you can then be able to try to reduce the number of replicas as needed, again in phases. We were able to reduce quite a bit on some clusters where it was just burning like replicas when serving either cross-region traffic or there was traffic from some regions that could handle traffic with a little bit of more on the latencies. But then again, if the SLOs are not impacted, we can allow that to happen. So that replication, so the replicas we try to reduce had a significant impact on the cost of some of the clusters. So coming up to the storage. So in AWS, we use AWS, so primarily what happens is like if you have clusters with high workload that uses provisioned IOPS. Now, a lot of times we observe that increasing the storage tier, like increasing the number of size on the storage would give the same amount of provisioned IOPS, especially with the GP3 volumes that we use. We don't necessarily have to have provisioned IOPS. So we reviewed that, and we were able to remove the provisioned IOPS feature and replace it with the standard GP3 volumes, and that was a significant storage savings. This is like an example where a cluster was initially using like a 500 gigs with if you see the provisioned IOPS, and it was up to 6,000 IOPS burning at 452 an hour. And then after the optimization of the storage, we increased the storage size from 500 to 2,000 gigs, and it effectively provided 6,000 IOPS and then reduced the cost to 310 an hour from 450. So that was a significant savings. So there were so many clusters like that we were able to bring in those kind of changes. Coming on to the backup. The story little on Indeed is that we used to have and I'm pretty sure a lot of companies today do have some kind of a compliance where you have to store your backups to an offsite for providing enough compliance for your requirement. And we used to store the offsite backup copies into AWS, and that would cost not only the storage cost on the AWS, but also the data transfer cost. So we had a talk, and there was a cross-region backup feature that got introduced in Atlas. So we replaced the S3 solution, which was transferring into AWS, to this cross-region backup, which was inbuilt feature. And with a backup compliance policy, we are also able to achieve the same amount of compliance. What we had in the, there are still some improvements that needs to be made in the backup compliance policy, but in general, with the combination of these two features, we were able to replace our custom solutions, which was transferring data into AWS to all within the Atlas realm, and that reduced a significant amount. I can't, again, say the numbers, but significant amount of data transfer costs were saved because of this combination of solutions. Then data transfer optimization. It talks mostly about the network compression. When you have some huge clusters with large workloads, that can take quite a bit when you are interacting with your from client and server and getting data back. It can cost significant amount of sum, and it will be shown when you see the Atlas billing. There are two SKUs, AWS data transfer, and since we are using the private endpoint, there is another layer on top of it to have the cost, and which will be an added cost to our clusters. So what we did was compress the data when query, and then when it automatically decompresses when the client gets response back from the server. And these are the basically, it's from official Mongo documentation, where you can have this implemented within your client settings. Snappy compressor, zlib or zstd compressor we can use. And that was able to save a good amount of cost for data transfer. And those SKUs were impacted because of this initiatives. And from here on, any questions on any of those slides, let me know. But here on, I'll give it back to.
Manan, there's a question.
Yes. Yes, because we are using AWS, I think in Azure, are you using AWS? Sorry, GCP. I'm not exactly quite sure on the GCP model, but Azure also offers pretty similar concept where you increase the tiers of the storage, and it will then provide the next level of IOPS for that storage. So then you don't explicitly need to check the provision IOPS, because we have observed that the provision IOPS checking is costing more in Atlas versus increasing the disk size. So in those kind of workloads, your disk will be, you don't probably need 2,000 gigs. You probably only need 50 gigs of data. But the reason we expanded it to 2,000 is because we needed those additional IOPS for our workload.
Yeah, in AWS, once the disk size is like 1,000 gigabyte, if you increase by 1 gigabyte, you get 3 IOPS. So we scaled IOPS through storage, and that was cost effective rather than going with the provisioned IOPS. This is quite faster, yeah, because we are not talking about the workload on the disk size.
Yeah, this is very instant. It's an instant change. There is no effect on the performance.
Okay.
But yeah, I'll hand it over to Chitradeep for further.
Thank you.
Ado.
Okay, so we talked about the premium feature and the optimization towards the beginning of this presentation. It's just a screenshot from the top 8 SKUs, stock keeping in it. So the premium services and support that consisted of Atlas entitlement, that is basically the Atlas support. And we have Atlas advanced security, LDAP encryption, and the enterprise auditing. So we were, back in 2023, we were in Atlas Pro support model, where this LDAP and encryption and auditing were chargeable. Those are the premium services for us. And as we are talking about the timeline of our migration, we completed migration from our indigenous platform, Quartermaster, to Atlas in November 2023, and the cost showed up, and the cost went up. So we evaluated our cost, we evaluated our support model along with the partnership of MongoDB team, and we decided that we should be going to the next level, not the pro level, but to the next level of support, which is enterprise support. And this is not only going to provide us a lower cost, because the LDAP encryption and auditing becomes free component there. On top of that, it adds additional benefit of the SLA. SLA is stringier SLA in enterprise support. The cost of Atlas entitlement goes up to a certain extent, but combination of these 3 costs was effectively low. So we were able to forecast that based on our analytical tools. We could see that we are going to be benefited out of this support. So we switched to the Atlas enterprise support. This year, this is the, we are not able to show the numbers. However, I can show you the percentage of drop. That 23% was the cost drop for these 3 components, these 3 SKUs, the month we switched the service to enterprise support, also getting the benefit of the support SLAs. Next point, the idle resources. This is pretty low-hanging fruit. Every organization do have idle resources. From time to time, we might have to need those cleanups. So we just didn't want to exclude this as a part of this presentation. We used op counter metrics. We used the Datadog op counter metrics. We pulled it there, and we identified the clusters which are idle, worked with the respective teams to decommission. There are other options that you can use is the analyze the database access history using the API. That can also give you a good idea about what the idle clusters, and of course the database audit history. Just a FYI that idle projects can also cost something if you're using private link. So it's not a lot, but it can cost some amount. So overall, the idle resource, even though it's a low-hanging fruit, it did provide us help with reducing 3% of the total spending, which is kind of quite a lot. So back to the objective, what we started with. Our objective was to reduce Atlas cost by 19%, and following all these various steps, following these priorities, we were able to reduce the cost by 27%. This is the graph from the IQL, the analytic platform we are talking about. So we kicked off this program in December 2023, and we concluded the program in June 2024, with 27% drop in our total cost. Yeah, that's all about it. So questions? Yes, please.
Hello.
Yeah.
This is Pradeep. I do work for some commercial airline. So the first question is, we do a lot of auto scaling, so we save some cost there. The cost, what we are trying to save is on the traffic, on the network. So do you guys use the combination of private endpoint and the VPC peering?
No, we use private endpoint only. We do not use VPC peering. However, as we mentioned about the data transfer cost, right? You can look into the compression. Just ensure that you test it properly in your QA environment. Ensure that the CPU is not highly utilized. But compression is something that you can look into.
Thank you.
Yeah. Any other question? Okay. Think you can?
Yeah. All right. Thank you, guys.
Thank you.